Hey, how you doing? My name's Elton. Welcome to Learn Docker in a Month of Lunches. This is episode 7, and today we're going to be looking at reliability when you're running multiple containers that comprise one big application. So there's when you're learning Docker, when you're starting to use Docker more and more in your work, there's a couple of things that you need to be aware of. So and this book kind of guides you on that journey. It's not just about the technology. It's not just about learning about the Dockerfile syntax and the compose syntax and running containers. There's a step more to that because Docker is an enabler for all sorts of different things, different approaches to building your applications. You can automate from start to finish when you've got containers in your pipeline, different approaches to architecture. So it's much easier if you've got like one big application. It's much easier to break that into smaller parts if they're all running in containers. So all the episodes this week are all about kind of part 2 of the book, which is about distributed applications that run across several containers, and that's made much easier when you're using Docker. But when you start breaking applications up and talking to each other across the network, you add more unusual failure modes. So like the benefit of having one monolith is that you get all the communications within one process. You don't have to hop across the network and look up another machine and wait for it to respond or anything like that. And as soon as you get distributed, you bring in all these other potential problems. But of course, containers have been around for a long time. There are lots of patterns established to help you deal with that. And today we're looking at health checks and reliability checks. So let me switch to my slides. So as usual, if you're new to this series, we're going to have a quick walk through the website, which is the homepage for the book. Show you all the links in there, which will kind of guide you around the experience of either just watching the series or buying the book and working through the exercises yourself. The bulk of today is about chapter 8, so which is called Supporting Reliability with Health Checks and Dependency Checks. And this is all about my distributed applications. They're all running in containers. If you give the container runtime some extra information, it can make your apps reliable for you. So it can take a lot of the burden of management away from you. And last of all, Q&A. So there's a Slack channel which you can read about all in the diamol.net website. You can join that and ask questions anytime. I'm usually hang around there when I'm awake. And then there's also the guide, the chat window in YouTube. So any questions, throw them in there. If there's time at the end, if there's anything interesting to talk about, we'll have a little Q&A at the end. Okay, but let's get on with what we're doing. So first of all, we're going to switch and have a look at the homepage for the site. So this is Learn Docker in a Bunch of Lunches. You can get the links here to Amazon and Manning right now. If you're watching live, there's a big reduction on the Manning website, so you can get the book for pretty much half price, which then frees you up some cash to buy other books of mine, like the Kubernetes book. You can get it on Amazon. That's the link to GitHub where all the Docker files are, all the compose files are. I don't print out every compose and Docker file in the book, and I don't go through them all in the YouTube series. But everything that I talk about is there in GitHub. That's the master. That's the kind of gold reference. So head there if you want to find out where all these things are. There's also the Slack channel. There's a short link for the weekly stream, which is happening through September 2020. And I've got a bunch of giveaways. The first lot went out last week. So 5 lucky people got a digital copy of the book. And thank you for your kind emails if you're watching, for appreciating for getting the book. I've got 5 more to give away this week, and 5 more next week, and 5 more the week after. So if you're watching live, head to that link. If you're watching recorded, head to that link anyway, because Manny often give me vouchers and stuff, and so I'll put them on that link if there's anything happening. Learn Kubernetes in a Month of Lunches is the sequel to the Docker book. Which is I finished the first draft and it's currently going through the early access program. That'll be launched early 2021, I think. There's a bit of detail there about what the book's about, and then there's a link to all the episodes. So we're on episode 7 today. There's also a playlist which has got all the episodes in there. And if you want more stuff from me, most of my other content is up on Pluralsight, which is a technology learning platform. It's mostly video courses. Most of my stuff are video courses. There's like a monthly subscription model, but there's a free trial. So if you want to check out the stuff that I've been doing, there's stuff there about Istio and Kubernetes and Docker and .NET, which is my kind of historical background. Whole bunch of stuff up there. So head there if you can't get enough of the sound of my voice. Okay, so let's get to the real stuff for today. So we're looking at chapter 8 today, reliability with health checks and dependency checks. We're in part 2 of the book, of the structure of the book, when we're looking at these kind of distributed applications in containers. The techniques I'm talking about today, they also apply if you've just got a single container and you're running your application in a monolithic model. You can still put health checks in, you can still put dependency checks in, but they really come into their own when you're breaking your application physically across different containers, as well as you might already have like a logical split of the layers of your app. But if you break them into physical containers, you can do more interesting things like scale, but you need to have the reliability built in. Okay, so this is what we're talking about today. So let me zoom in a little bit. We're on this journey. We're on this journey together to making software production ready in containers. There's a whole section of the book that deals with production readiness, but we're starting to get the best practices in pretty early. So we've already seen that when you run your applications, we've used Docker to build our images, to run our apps, and we've used Docker Compose as well. In production, you'll have a platform. You'll be using either Docker Swarm or Kubernetes, and they have extra features that can keep your application healthy for you. So in the best case scenario, if there's enough detail in your Docker image and in the model of your application deployment in your YAML files, then the platform, Swarm or Kubernetes, will just keep your app running under any kind of normal failure scenario. So if something goes down, the cluster, the orchestrator, will bring up a replacement container somewhere else. Like if a whole server goes down, takes a bunch of containers with it, the orchestrator will start up replacements elsewhere. If there's a problem with your app, then it can restart the container, it can do other things. But to do that, you need to give it some information. That's what we're covering today. So there's this idea of understanding the health of the application that's running inside the container. And Docker already has this kind of basic mechanism that when you in your Docker file you have a command instruction or an entry point instruction, tells Docker what process to run when you start a container from the image. And Docker monitors that process. So when it runs a container, if the process is running, then the container is in the up state. And when the process finishes, then the container is in the exited state. So if there's a catastrophic failure in your application and the process bombs out, then the container goes into the exited state and you know that it's no longer running. But what Docker doesn't do is understand what the application is actually doing and whether it's really healthy. So there's a good example here. This is a kind of standard example. If you're running a web application, the web server process could be running, but your container could be completely maxed out. So it's unable to process any new requests. And when an HTTP web server is getting more requests than it can handle, instead of returning a 200 OK response with the payload, they return a 503 error. Service unavailable. So it could be returning that to every request, but all Docker's doing is looking at the process, which is still running, so it thinks the container is healthy. So in that case, the platform wouldn't do anything, wouldn't take any repair action because it doesn't think it needs to be repaired. Okay, but there is a built-in feature in Docker which will help you do that, which will let you define a health check so Docker knows if the application is actually healthy. We'll see that shortly, but before we do, we're going to run an application that goes unhealthy when you use it, and we'll see exactly what the problem is. So just as before, you can run all these exercises. It's very exercise heavy. This book gets you experiencing using Docker and gets the feel for working with the commands. All I'm going to do is run through the exercises here, but I've already pulled the images. So I've already pulled the images for today's episode, so you're not looking at the download happening. So I'm going to do Docker container run. There's nothing new in this command. I'm running this in the background. It's an API that returns you a random number. It's detached. I'm publishing port 80, and that's the name of the image there. So it's going to start up and sit there in the background. It's detached, so all I get is the container ID back. Now, if I run curl and call into this command, call into this API to get a random number, and curl is on Linux and Mac boxes, and on Windows 10, the latest version of Windows all have curl installed. So you can just run this command, and it's just going to make a GET request to that API running in my container. And I get 84. So I just get around. That's literally all I get is the number back. If I repeat that, I get another number. Repeat it again, I get another number. But the code inside the application is set to trigger. So after 3 calls, it will always fail. So now if I do it again, I get this error, and it's a 500 error. And I get this lump of JSON back. So now it will always fail. So if I repeat that again, I'm still going to get another failure. Now, if I look at the container status, which we will see here, Docker thinks the container is healthy because the process that's running inside that container, this is a .NET application, so I use all sorts of applications in the book, all sorts of languages, Go, Java, Node.js, .NET, so you get a feel for how Docker works in all of those. This happens to be .NET Core. So the .NET process, which is this here, the command that spilled over the line, the process is still active. So as far as Docker is concerned, this container is all good. It's been up for 51 seconds. It's still working. But of course, the app isn't actually healthy, but Docker doesn't know that because I haven't told it how to test if the app is healthy. Okay, so if we scroll down here, there's some stuff in here, and this is where we talk about the health check instructions. So when I introduced Docker files in earlier episodes, we're really starting with the basics, and in further episodes and further chapters, we add more and more information in there when you understand the task that it helps you to achieve. So in this chapter, we're talking about reliability, and this is where the health check comes in. So the health check is a specific instruction in the Docker file where you specify a command that Docker will run periodically. So what we're going to do, let's switch right down to an example here. So that's the output of the previous exercise that I've shown you. So let's have a look. This is a simple example. This is just got an entry point command to run my .NET application. And then inside there, there's also a health check. So this is a first-class Dockerfile command. It's part of the Dockerfile syntax. The health check command then takes a specific command to run, and the command to run is curl, and with the flag to fail, and it's going to call localhost/health. So this is a different endpoint from I've been calling the RNG endpoint in my tests, which gives me a random number. There's also a health endpoint in the app, which whether it's returning random numbers or not, the health endpoint should always return. What this does is it tells Docker that periodically, and by default, it's like every 30 seconds, it's going to run this command inside the container. So in the container, I'll be looking at localhost. It'll run the curl command just like I have from outside, but inside the container with the fail flag, which means if there's any problem with the HTTP request, if I don't get a 200 response, then the command will error. And when the command errors, then Docker knows that the health check has failed. Okay, that's only part of the Docker file. The rest of it's all in the source code. You can see it just uses a standard kind of multi-stage build that we've talked about in previous episodes. Okay, so now if I build a copy of this, and I think I'm already in some weird directory because I've been working through this before. So if I go and look at the exercises numbers, okay, so this is where I am. I've gone down too far. Let me go back up here. So I'm going to build a new version of my image that uses that Docker file. So this is the Docker image build command. The reason I'm showing you this is because there's a different syntax from what you've seen before. So again, as the book goes on, we unfold kind of more and more aspects of the commands that we've introduced already. So Docker image build, as before, it's got a -t, which is the tag. I'm calling this DIAMOL. I can call that use that organization name locally, but I couldn't push this to Docker Hub unless I'm authorized, which I am. I'm calling it Numbers API v2. But the Docker file doesn't live in the same location as where I'm running the command. So the -f parameter tells Docker where to find the Docker file. So it's saying you're going to go from the current directory, you're going to go into the Numbers API directory. There's a file called Dockerfile V2. So by default, you do Docker image build, you give it a tag and put the dot in there, which tells Docker that we're starting from the current directory, and off it goes. If your Docker file isn't called Dockerfile or it's in a different location, you use the -f flag and you tell Docker how to find it. Okay, so that's all that's different about this image build command. So I've already run this before, so we should see that everything comes from the cache, so that's all good. And we can see in there that this Docker file does have the health check that we've just looked at in the book to run to make a curl call to localhost every few seconds. Okay, so cool. So now I've got a separate build of the same application, which is on my local machine. So if I clear this down, I'm going to do a Docker container run to start an alternative version. So again, same kind of deal. I'm running the image that I've just built. It's attached. I'm publishing a port. Port 8080 is already allocated with the other container, so I'm using 8081. Let me do a Docker container list. So the wait 30 seconds guidance here is for the health check to kick in. So Docker will run that health check straight away, but it won't get a report until after the run is completed, which will be up to 30 seconds. So what you see here is a slightly different output. So the one that I started first, it just says up 5 minutes. The one that I started now, and again, it scrolls over the line, it says up 17 seconds, and there's a bracket, and it gives me the health status. And the health is starting, which means that it's the first health check hasn't returned to say that it's healthy or not yet. Let me try that again and see if it's come back yet. And this time it has. So now it says up 42 seconds. This is the suspicious Feynman container, and it's healthy now. So it's run that health check inside the container. It's run the curl command. It's got a 200 response, so it knows everything is good, and it returns back to Docker to say the container is healthy. So let's clear this down. I'll do the same thing I did before. I'm going to make a call to my local host 8081. So this is the published port on the new container. The code is the same, so I'll get my random number 1, 2, 3 times, and now it will fail, and it will keep on failing all the time. But failing from the outside is now going to trigger the health check to have failed as well. So it'll take 30 seconds to realize, more actually, because Docker has to record a failing streak. It doesn't just say, it's failed once the container's gone bad, it has a number of consecutive failures that you have to meet for it to be deemed unhealthy. By default, that's 3. So if I look at Docker container list again, what we'll see is it's not in a failed state yet, because I should wait 90 seconds as the exercise says. We'll see it's still currently healthy. But we'll come back to this in a second, and we will see that it's turned into an unhealthy state because the health check is firing, and it's now returning 503 inside the container when Docker runs the health check. So we'll see the output here in the book, but I'm going to scan on to the next exercise, because that's going to show us a bit more detail about what's happening. So we've already looked at the Docker container inspect command that gives you this big, huge chunk of JSON. And we're going to look at that now. When you have a health check defined in your Docker image, then every container runs its own copy of the health check. So if I have multiple containers from the image, I would see they each run their own health check. And the inspect command shows me the run of the health checks and the output of the most recent health check. So I'm going to do a Docker container inspect, but I've got some other magic here, because I don't know the ID of this container without looking at it. I didn't give it a name because it's just a throwaway container. If I run Docker container list, then I get that out, which is all my containers that are running. If I use the last flag, it will show me the most recent X containers. So -- last one gives me the most recent container, which is now flagging as unhealthy. And if I format that to just get the ID, so these are all nice little features of the Docker commands that you can use to kind of automate and script the things that you want to do. So this just gives me the ID of the most recently created container. So it's a nice little feature to have there. And I can pipe that into the Docker container inspect command. So this will say Docker container inspect the most recent container effectively. And inside here, I've got all this tons and tons of JSON. I need to scroll quite a way up here. I'll see all the environment variables. I've got all the physical locations of all the layers and that make up the file system that we talked about, and then all the options that the container was started. And way up here, I've got the output of my health checks. So what we can see here is my health report. The status is unhealthy. Failing streak is 4. So the last 4 health check commands that were executed have all failed. So now it triggers into being unhealthy, because the default is 3 to trigger it as being unhealthy. And then I can see the logs for the most recent health checks. So down here, I've got here we are. So the server returned a 500 there, internal server error. If I scroll on down, we'll see that I'm getting errors back from all of them. So that's the same error that I saw myself. But now Docker knows the container is unhealthy, and so it's triggered as being in the unhealthy status. So all the way down through there, we've seen all that stuff. When I did my recording here, when I got my screenshot, I waited a bit longer, and my failing streak was 6, and you can see that the same thing. So I get an error back when the curl command runs inside the container. It exits with a non-zero error code, non-zero return code, and Docker treats that as being the health check has failed. If you return with a 0 code, which is the default in Linux Linux tools, then it says the health check is healthy. Now it's going to keep firing that health check, and if the app had repaired itself in some way, then it would trigger back to being healthy. So it doesn't just stop because it's unhealthy. But what happens is it doesn't do anything. So if I do my container list again, let's have a look at that, which is down here somewhere. I've still got my 2 containers that are running. The one that's up that's broken, but I don't know it's broken, has been up for 10 minutes. The one that's up and I do know it's broken because it's unhealthy is still up. So Docker is not going to kill that container and start it with a new one from the same definition, because it can't really do that on its own. So an orchestrator could do that. So Kubernetes or Docker Swarm could do that, but on its own, Docker can't really safely do it. So I talk about this in this chapter here, in this paragraph here. So it could stop and start the container, but there's only one container. So that means downtime for your application while Docker takes that kind of repair action to deal with the container having failed. Or it could say, well, I'm going to get rid of that container and start a new one. But Docker doesn't know if your application's been merrily writing data inside that container. So if it stops it and creates a new one, then you could lose data there. So it doesn't know what to do, but what it does is it flags it as being unhealthy, and that comes in useful when you're running in a container platform like Swarm or Kubernetes, because what happens is the Docker API. We know that the Docker command line, the Docker Compose command line, they just call into this Docker API that's exposed from the Docker engine. It has a REST API element, so you can do GET requests and list your containers and do a post to create a new container. But it also has a streaming API, and you can subscribe to that stream and get events published. and you will get an event published to say a container's become unhealthy. So you're, in the case of Docker Swarm, it knows that a container turns unhealthy, and then it can do something about it, which could be to replace it with a new container, which might run on a different server, or to restart the container if it's unhealthy. Okay, and like in an orchestrator, there should be additional capacity. So you should have you should be able to spin up a spare container somewhere else, and then Docker will replace the one that's turned unhealthy. So you shouldn't have any application downtime. So this is how adding the health check just kind of adds to the reliability of your application. The orchestrator can repair it if it goes wrong. Okay, and the second part of this is, so your health check is the ongoing thing. It's firing all the time, telling Docker whether it's healthy or not, and then Docker will publish that event if it goes unhealthy, and whatever's managing Docker can then take evasive steps itself. But there's also this notion of dependency checks. So health checks are built into Docker. Dependency checks are more like a best practice, which you probably want to put into your applications, depending on what your application does. So think of a distributed app where one component has a hard dependency on another component or a set of components. Like, it literally cannot do anything unless those components are available, like a web app that needs a database to do anything. So in that instance, then when the container starts, especially if it's kind of got a legacy background, or if it's been built with this assumption of availability, then the app, when it starts, won't check that its dependencies are available. It just assumes they're available. So maybe, the web application will throw up the home page because it can do that by itself. It looks healthy, but as soon as you click on any links, then it tries to connect to the database and it fails. And you don't really want that, because that's problematic, because it means that it looks like the app is healthy again, but it's not actually functioning. So you get this kind of illusion that everything's okay. We got an example here. So I've got a website that goes with my random number API, and the website calls into the API to get a random number, and it shows it to you. So it has a hard dependency on the API. It can't really do much without that other than render the home page. So we'll switch on to this exercise here. I'm going to get rid of all my current containers. So this Docker container list command shows me all containers, whether they're running or not. That's the A flag, and the Q flag just shows me the ID. So the Q means quiet. If I pipe that into Docker container rm-f, then that's going to remove all containers, whether they're running or not. So forcibly stop and remove all containers that I've got there. So it clears the system down. Way back in chapter 1, there's a note of that command, because it's a useful one, especially in dev environments or test environments that you can safely clear down. It just gets rid of all your containers and frees up everything that they were using. Okay, including ports and disk space and compute space and all that sort of stuff. So I'm going to run the web application. So previously we've just run the REST API and we've called it with curl. Now we're going to run the web application. We'll do a list to make sure it's up and running, which it is. So that looks good. I've published port 8082. It shows that it's up. I can see from the output there of the status, there's no healthy there's no health response. So it doesn't have a health check built in. Otherwise it would say health starting or healthy or unhealthy. Okay, so my container's up and running. Now I'm going to browse to localhost 8082. So let's switch back to Firefox here, which is obviously currently all full of my adverts. If I browse, I've copied the wrong thing here. So let's just do 8082, which I've got here. Here's my numbers website, so I can click on. Looks good. So my application's up and running. There's a link to the source code there, which pings me off to GitHub. There's a big button here to get a random number, so everything looks fine. I click that, wait a few seconds, and I get an error. So it says RNG service unavailable. So this application does have some error handling. I don't just get a big ugly error page, but obviously it gave this sense of false security that the application looks like I can do something, but I can't. In this case, there's an extreme example. There's only one feature on the app and it doesn't work. And I don't know that from the outside. As an operator, the container's up and running, everything looks good, but the app doesn't actually work. Okay, so this is where a dependency check comes in. So what we're going to do, let's close this down and have a look at what's coming up. So there's the output you see. Same thing as before. You'll get the same thing if you try this exercise yourself. So this is when you really don't want this to happen. And some apps might have logic built in when they start up to say, I'm going to check the database is available. I'll check the message queue is available. I'll check I can access all the disk paths that I'm going to write to and need to read from, all that sort of stuff. Most of them don't. So most applications, that's the kind of nice thing that you put on at the end, unless you've got some good coding practices right from the start. So in this case, this is different from the health check. Docker doesn't have this notion of a dependency check that's part of the Dockerfile syntax, but you can put it into your startup command. And there's another important pattern here, whether you use this for dependency checks or not. So far, we've looked at command instructions in the Dockerfile. They just do one thing. They just start the application. Well, actually, your command instruction can do a whole bunch of things. Most of the official images on Docker Hub, if you look at the Docker files, the command instruction calls a script, like a bash script or a PowerShell script, that sets up a whole bunch of interesting things. And you can do whatever you need to prep the container environment before you run your application. So, if you've got a legacy application that can't read configuration from environment variables, then in your script, you might read them from an environment variable, and inject them into a file. If you've got a legacy application that writes logs to a file, you might set something up that echoes them out to the standard output stream, all patterns that we'll see later on in the series. In this case, what I'm doing, I've got two commands in my command instruction. The first one is a curl command that calls numbers API /RNG. So this is making a call from the web container to the API container. It expects it to be called numbers-API. And then if it succeeds, it will run the application with the .NET command. So that double ampersand here, that works in Linux and Windows, and it means run the command on the left. If it succeeds, go ahead and run the command on the right, which is my .NET command. If it doesn't, then fail. So what will happen is when this container starts, the new version of the web application, when it starts up, it'll run that curl command first. If it can't reach the API, then it won't run the .NET command. So the curl command will run and finish. Nothing else happens, so the container will exit straight away. Okay, so let's go and have a look at this. So that's the stuff I was talking about there. Let's clear this down. On to the next exercise. So I've already built this image. So all the images that I work with have already been built and put on Docker Hub. In some cases, I get you to build them as part of the exercise, so you can see some new feature of the build of the image build command. So same as before, I'm going to run this detached, some other random port 8084 this time, and this is CH8 numbers web version 2. So this is the new version of the application, the web application. This has that dependency check built in. Okay, so if I do a Docker container list --all, if I can grab it correctly. Okay, so what I will see now is I've got my original application that's been up for 4 minutes, and that's still up. So that's the one that's published on port 8082, the one I browsed to. I clicked the button and it failed. That's still up. The new container, which has just been started, was created 20 seconds ago, and it exited 18 seconds ago. So it started, it ran for a couple of seconds, and then it exited. So it ran just long enough for the dependency check to fail. So it tried to call the API. There is no API. Effectively, that application cannot do any work, so it exits. Now, it seems, as I write here, let's close this down. Like, this seems counterintuitive. This does not seem like the thing you want it to do. Like, why would you want your container to exit straight away? The reason is this is fail fast. So the application in the container can't do anything. So there's no point it running and making you think that everything's okay. So, and this is important when you're running it in an orchestrator, because we've seen in Docker Compose, you can have this depends on flag. And in your service list inside your Compose file, you can model the dependency graph of your application. So if I was running this in Docker Compose, I would say that the API, I would have the API service definition, I'd have the web application component definition, and in the web service, I would say it depends on the API. Docker Compose will make sure the API container starts first before the web container. When you're running at scale in an orchestrator, Docker Swarm or Kubernetes, you can't model that sort of dependency graph easily. In some cases, you can't model it at all. And even if you can model it, you probably don't want to, because you're shackling the orchestrator's ability to do its job. The job of the orchestrator is you tell it what you want the end result to be. I want to have 50 API containers and 30 web containers running across the cluster. Now, if you try and model some sort of dependency in there, then the orchestrator can't start everything up as quickly as possible. Like, it needs to start all 50 API containers, make sure they're running before it starts the web containers. And then what if there's a problem with one API container and only 49 are running? Does it start the web containers or not? So it can't just work as quickly as possible. What your orchestrator wants to do is to say you've asked it for 100 containers of different images that do different things. It wants to start them all as soon as possible, and for them to work out amongst themselves which ones can do their thing and which ones can't. So by having this kind of dependency check in there, It starts as a bunch of API containers, starts a bunch of web containers. Some of the web containers fail because they try and talk to an API and they hit a container that isn't ready to service requests yet, or the web container starts before any APIs, and so it exits. That's fine. The orchestrator sees that it exits. There are only 15 web containers when there should be 30, so it'll start another 15. So it can take evasive action. It can repair your application for you if it knows there's a problem. If it doesn't know there's a problem, then it can't do anything there. This dependency check thing doesn't work in all scenarios, but in a scenario where you control the dependency, so in this case, I control the API. It's not a third-party platform thing that I can't really do anything about it not being available. I can make sure my API is there. If there's a problem, I can fix that myself. So this is where dependency checks come in. Okay, and it makes it a good citizen in your container platform. So like Docker and Kubernetes, they will run pretty much anything in a container. They don't really care what the application is inside the container. But if it's a good citizen, if it tells the platform whether it's healthy or not, if it tells the platform whether it's ready to do its work, then whatever's running it can run it more effectively. Okay, so there's the output there that we've just seen. So it's exited, it starts, and it exits. Okay, so you can have a dependency check in there, so that's all fine. So far, we've used curl, and that's great. Like curl is available in most of the kind of base images. The problem with curl is when you start using it for more advanced logic, your scripts get a bit more complicated. So your Dockerfile gets more complicated because I've got these curl things in there as part of my health check. Maybe I've got dependency checks that use curl as well. There are some disadvantages with doing that. It's difficult to read. It's difficult to have a conditional logic in there because you're expressing it in a scripting language, and maybe you want to do something really slightly more complicated, like say make sure the response is 200 and it comes back within X number of milliseconds and X, Y, and Z, and I'm going to inspect the payload that comes back. Can't easily do that in a script. The other thing is you have a dependency now in your container image to have curl available if you're using curl for your health checks and your dependency checks. And the problem with that is you probably don't need curl. Like you don't need curl in your application to do its work. It's an extra dependency that you're taking on, and as soon as you bring that on board, you've got more software that you need to package with your application image. And one of the goals, of course, in optimizing your image is to only have the bare minimum that you need to run your application. So instead of using curl, it's better if you can write your own little dependency check tool. So if you've got a Java app, then write a Java tool that you're going to use for your health check and your dependency check. If it's Node, use Node.js. So you build another little component that does exactly what you want. So it does all the logic that you want. It's expressed in the same language that your application is written in. It can use the same configuration files that your main app uses and all that sort of stuff. So it's a lot easier to integrate with the rest of the workflow, and you reduce the dependency on having a third-party tool. You don't need to install curl because you've already got Java if it's a Java application. So you're not installing anything extra to get your health checks up and running. Okay, so we can do all this stuff. And as an example here, so kind of going back to the multi-stage builds that we covered in episode 3, this is another example where I could have another stage in my Docker file. So in this example, I'm going to build a stage that's going to compile my main application, and it'll produce a whole bunch of binaries, which are the main application. Then I've also got a dependency check builder, which again uses the SDK image that my application uses. So .NET if it's .NET, or Java if it's Java. Copies in the util folder, the utilities folder, and builds that. So I've got two sets of binaries. In the builder stage, I've got the application. In the check stage, I've got the utility, the check utility. And then in the final stage, I'm starting from the runtime image, which would be my bare minimum image, copying in all the utilities that are the health check, copying in the full application. And then in my health check command, I'm going to call the utility app instead of curl. And in the final command, I can put my dependency check. I can call the utility as well. So there's no curl in the final image. It's only got what it needs to run the app. And in the source code, I've got the nice clear checks that I want to run. So I can do all sorts of nice things like retries and use whatever libraries that I use inside my application and use the configuration that I'm using for my main app. So there's a whole bunch of advantages to this. It does add more stuff that you have to build and you have to own, but it gives you a lot more flexibility. So if you've got complicated requirements for your health checks, if you don't need curl for any other reason or any other tool, it doesn't have to be curl, then this is a nice way of doing it. Okay, so we've got an example in here. This is Dockerfile V3. So let's switch to the Dockerfile so we can see this in its entirety. Where's my Explorer? There we go. Okay, so we're on chapter 8, exercises, numbers web Dockerfile V3. Oh no, I'm looking at the API. Numbers API, Dockerfile V3. Okay, so standard kind of Dockerfile syntax that we've seen before. There's a build. This is really the embodiment of that graphic that we've just seen. The builder stage copies from the source code. It copies in if you remember from the previous episode, we have this two stages where we copy in the package reference file and then do the package restore. We did that in Node.js, we did it in Java, we did it in Go. This is how it looks in .NET. So I copy in the project file, which contains all the dependencies, and run .NET restore. And then I copy in all the rest of the API source code and do a .NET publish. And then I've got another builder stage. So this is for my HTTP check utility. It starts from the same SDK image. It follows the same pattern. So there's a different folder there where I've got the utilities source code. I do just copy in that project with its dependencies, and I do a restore. Then I copy in the rest of the health check code and do the .NET publish. And I've got these two separate stages with 2 bits of output. And then in the final stage, so this is from the runtime image. So this is the minimal image. I've got my 2 things in here. I've got my entry point, which is telling the .NET API to run. And I've got my health check command, which uses the .NET utility. So it's going to call the .NET runtime. It's going to call this HTTP check utility and pass it a URL to check. So the health check, instead of running curl inside the container, it runs another .NET application. So the main .NET web server will sit there in the background, and a new .NET process will start every 5 seconds, every 30 seconds, and it will make that call, check that the application's healthy, and then respond either with a 0 or a non-zero return code, so Docker knows whether it's healthy or not. And then the final thing we've got in here, I create a working directory for the application binaries. I copy everything from the HTTP check. So that's the thing I use in my health check. And I copy everything from the builder. So all the application binaries, all the config, everything else, and the health check utility all ends up in this app folder. And we use that to run the web server and to run the health checks with the separate binaries. Okay, so let's get rid of this. We're going to see that in action now. So let's clear this down. Scroll down to where we get to the next exercise. So again, we're going to get rid of everything we've got so far. So it's a kind of brutal way to clear down your current state, but I'm not running any of the containers, so that's fine for me to do. It's only containers for this episode. And then I'm going to run V3 of my API container. So again, nothing much new here apart from this health interval flag. So the health interval is saying, how often do I want the health check to run? And the default is 30 seconds. I'm setting it to run for 5 seconds now. So every 5 seconds, the health check will fire. The health check command in the Docker file will run that .NET utility, and that will respond to Docker with the status of the container. So let's go and look at this. If I do a Docker container this now, I should imagine I've been speaking for at least 5 seconds. So right away we can see it's been up for 23 seconds and it's healthy. So in that time, the health check would have fired probably 3 or 4 times. And it's coming back as healthy all the time. So that's looking good. The API is still broken. So if I call the random number endpoint and call that in 1, 2, 3, 4 times, now it's broken. So if I clear that down, now the health check will start to fail. But again, I've overridden the interval for the health check, but I haven't overridden the number of failures that constitute an unhealthy application. So the default is 3. So it'll wait for 3 consecutive failures, 5 seconds in between, and then it'll flip to being failed. The reason why we have this kind of failing streak is to try and avoid the situation where a container kind of flips in and out of being unhealthy. So maybe it fails a health check and another health check, but then it's good again. Well, I wouldn't want the container to be flagged as unhealthy and potentially the runtime, the platform that I'm using to replace it, if it's just had a temporary failure. So that's why we have the failure streak, the 30-second interval, the three consecutive failure streak. Those are kind of sensible defaults. You'll probably tweak those in your production apps. Probably been talking for 15 seconds now. So yeah, we're looking at unhealthy. So it's been up for about a minute. It's still up, but it's not healthy. So it can still process things that come in, but Docker knows there's something wrong with it. And if I were running in a platform that ran containers for me, it could do something about it. Okay, so this is failing. I also have a version of my application, the web application, that uses a dependency check, and it follows exactly the same model. So inside the Dockerfile V3 for the web application, you'll see it in the source code. It's got a builder stage to build the web app. It's got a builder stage to build the utility, the dependency check utility, and in the command, it's the same pattern. as we saw before, where it ran the curl command. If the curl failed, it can't reach the API. Then the container exits. If the API is available, then it will run. The difference here is that I'm not hard coding the URL for the API. So because I'm using .NET for my web application, it's got a configuration file. It knows how to look up a setting in a configuration file. So my web app is configured to look in a specific place to go and get the API. And my utility is using the same configuration file. So this is like custom code, but I've written the code for my utility to say which configuration settings should I use for the API for the URL that I want to go and check. And this is the setting that the web app uses too. So if you've got complex kind of health check requirements, it's a really nice way of being able to separate the health check configuration and not having to duplicate that inside your Docker file, because it will share the configuration from the application that you're using. Okay, cool. So that's how that looks with the web component. This is just the exercise we've already seen. And if we now go and run the web component, it will talk to the API, but the API is broken. So it will return a 500. And what we should see when this starts up, if I look at my container list and look at them all, we should see this exited as well. So my API container is up, but it's unhealthy. When the web container started, it did make a successful, it managed to call that API, but it got a 500 response because the API has gone bad. So it exited straight away. So it's the same output as when I was using curl, but now I've got a lot more control over the what I actually do inside my health check using my little utility application. I don't have to duplicate any configuration. It's also a nice way of saying that my the utility that lives inside my container image, I don't necessarily have to use the Docker semantics for my health check and my dependency check. So when I run a Docker container, if it's got a health check defined, then Docker will run that health check. If I'm using Docker Swarm, again, it'll run the health check when it sees that there is one defined in the image. Kubernetes is different. It kind of ignores the health checks that are in the image. It has a different way of modeling how you check your container is healthy, but it doesn't really let you do like complicated logic in there. So if your image has got your utility that can do the health check for you, then you can call that. You can set it up to work with Kubernetes or Swarm or Compose, or just with running a container. Okay, so that's up and running. That's all looking good. So the next thing is, obviously, we're talking about multi-container apps. And so far, I've just been doing a Docker container run, Docker container run, Docker container run. And that's not great, because obviously I've got a multi-container app here. And we learned in the previous episode, we had an introduction to Docker Compose. Docker Compose, the full Docker Compose specification is really big. We've only seen a small amount of it. One of the things you can include is when you're in your service definitions, when you're listing out your parameters that will go into the container setup, you can specify health checks in there. So you can specify, you can override the settings for the existing health check inside the image, and you can specify a completely new health check if the image doesn't have one. That's what we're going to look at now. So if we go and look at, this is my Docker Compose inside the numbers folder. So let's go and look at that, because that's better from looking at the source code view. So mostly the stuff that we've seen before. So we've seen, like, there's the version flag, there's the list of services. I've got my numbers API. I'm using V3. So this is the thing that's got the custom dependency check. I've got the port, so I'm exposing port 87. Right at the bottom here, I've got the network. So this is the virtual Docker network it's going to connect to. The new thing is the health check. So I've got the health check specification here. There's no new command, so it'll use the health check command that's defined inside the image, which uses my utility. But I am configuring the parameters of the health check. So I'm setting the interval to be 5 seconds, just like I did when I did Docker container run. The timeout is 1 second. So it's expecting a really fast response, because it's just making an HTTP call to localhost. So it should be super fast. The number of retries is what specifies the failing streak. So it'll only retry twice instead of 3 times. And then the start period, which I've got, is 5 seconds. That's like a grace period. So it'll wait 5 seconds before it runs the first health check to give the application runtime time to fire up. There's no point in the very first health check always failing because the app isn't ready. You might as well give it that startup period. So the second service is my numbers web service. So again, there's some things we've seen before. So it's called numbers web. It's using my version 3 web image. There's an environment variable set. So Just like with the Docker container run command, you can pass environment settings. You define them here inside Docker Compose. I'm specifying the ports to publish, so the web app will be available on port 8088. But I've also got some other stuff in here. So I've got a restart on failure option, which means that if the container fails for whatever reason, then Compose will restart it. So Compose can do some of the things that an orchestrator can do, but it's only running on a single machine. So it will restart this container if it fails. There are other values of the restart flag to say, it will always restart. So if the Docker engine restarts, the container will restart. If the server reboots, then the container will restart. This is just saying if this container fails, start it again. And I've got a health check defined in here. So there is no health check inside this image. It just has a dependency check. So I'm specifying, excuse me, a health check here. The test is the command to run, which is my .NET utility. Again, the same little help HTTP check utility. And I'm specifying the interval, the timeout, the retries, and the start period, just like everything else. So in my API, the health check configuration is using the command that's defined in the image and just tweaking the options. In the web application, there is no health check in the image, so it's all being specified inside the compose file. And in addition to that, we've got this restart flag, which will replace the container. If it starts up, the dependency check runs when the container starts. If the API isn't available, then the container will fail and Compose will start a replacement container. And right at the bottom there, I've got my network definition. Losing my voice today. Not quite sure why that is. It might be because I'm doing this every day. Okay, so these are all the details of the things that I've just walked about here. And we will go and we've seen adding the health check in there. So we've seen all those pieces. That restart flag is really useful in Compose. If you're using Compose in test environments, non-production environments, because in production you'll probably be using an orchestrator, then it's really good way of making sure that your test environments, your user testing or your system test environments, your integration test environments, making sure that the containers are always there. So if something fails because there's been a bad release, then it starts up again. You can start tracking down what's happened. Okay, so we are in here. Where am I now? I'm inside numbers already, so I should have my Docker. There it is, Docker Compose in crossword format. So I'm going to clear down my existing containers again, so give myself a nice fresh sheet to work from. So that'll get rid of the existing API and web containers. We'll start out with Docker Compose. So again, we talked about this in the previous episode. One of the big things that Docker Compose gives you is this single file that defines your whole application. So far I've been doing Docker container run. I've been specifying the ports in the run command. I've been specifying the health interval. I would have to specify the network to plug these things together. That's all in my Docker Compose command. So I can do Docker Compose up. I don't need to know anything about how the app's configured, and I can just run that one command and be up and running. Okay, so wait 5 seconds, which I probably have. I would have a sip of water at this stage, but my water bottle is empty. So let's clear this down. So Docker container list, I will see now I've got my API container. It's been up for 30 seconds, so it's healthy. So that has the health check defined in the image. It's only set with a 5-second interval, so it started up pretty quickly and it's come back as healthy. And then in my web container, which is the second container, that's showing as healthy too. That image does not have a health check defined. That's defined inside the compose file. So this is kind of what I was talking about, that if you've got this utility that's packaged inside your image, you can call it and configure it in different ways. So you can configure it in your Docker file, you can configure it in your compose file, your Kubernetes YAML file, whatever it is you're using to call into your application to make sure it's healthy. But you can have more complex logic if you've got a binary in your application image that understands how to make that health check for you. Okay, and if I go and look, the other thing to see here is that this one, the numbers web, I should see something in the logs, which hopefully will look the way I expect it to look. Okay, cool. Yeah, that's exactly what I wanted to see. So what isn't in that compose file is the depends on option. So I haven't got a dependency mapped that says the web application needs the API to be running first. So there is no dependency inside Compose. So Compose doesn't start one first, it starts them both together. So my applications are up and running. What happens then is the dependency check starts inside my web container and it gets an error. So the container exits. But because it's specified inside the compose file to restart on failure, it just restarts immediately. So this is the same container, same set of logs, but it starts again. By the time it started the second time round, the API is up and running. So this is how the dependency check and the health check really work together nicely. So I've just told Compose start these containers up. It's not waiting for one to start before it starts the next one. So I don't have that modeling of my dependency, which I can't really take forward into production. I'm just letting them all start at the same time. The web container hits the API when it starts up, and the container is not ready. So in this case, well, I can see the exception at the top here tells me connection refused, which probably means that the API has started, the container has started, but the app isn't running yet. So I just get a TCP connection, so I can't go and call the API. So this container exits; it can't do anything, and then it starts again because Compose is managing this container. It restarts it, or rather, it's told Docker Engine that this container should be restarted if it fails, and then I get my HTTP check. My HTTP check is being okay, and it tells me it got a response within 100 milliseconds. So now it's up and running. The rest of the logs, standard application logs. Okay, and that's what we see in the output here in the chapter. So the same thing happened. No, actually, the different thing happened here. So there are different ways for this application to fail its dependency check. The first dependency check took too long. So if you go and look at the source code for this utility, this dependency check utility, it does a stopwatch to see how long it takes for the response to come in. And inside my, let's go back to my compose file here. Let's go inside my compose file. In my .NET utility here, this T flag tells the utility how long it should wait before it considers that the call has failed. So inside, when I ran that exercise for the book, what happened is it took longer than 900 milliseconds, so it came back as failed, and then the container got restarted. So in this case, I'm getting an error when I ran it just now because it started up too fast. When I ran it in the for the screenshot, it succeeded. It got a response back, but it took too long. So my dependency setup, you should be up and running quicker than that. Okay, so this is the part that I was talking about here. Like, you could model this with a depends on flag, but you're not letting you can't really carry that forward into a production environment because your orchestrator doesn't expect to be told start this container, then start this container. It's the orchestrator's job to choose when to start containers, and it could start them in any order, and there could be any number of them on any number of servers. So by having the health checks and the dependency checks inside your container, so it can tell the platform if it's healthy, it can tell the platform whether it's ready to start work, then the platform can manage whether that container is good or whether it needs to be replaced or restarted. Okay, cool. So we see that. Oh, and now I should be able to browse to this. So it's 8088 because the API is healthy, and because the web component restarted. And if I do get a random number, there we go, 32. And as it says in the book, was it worth the effort? Well, it's quite a long chapter, so that is a joke. So if we get rid of the terminal here, so the end of the chapter is really just kind of making sure that you understand why this stuff's important. So really, we've only covered a couple of new bits of the Docker world. So the health check syntax inside the Docker file, the ability to have multiple lines in your startup command so that you can do something before you run your application, and the ability to configure your health check parameters and the health check itself inside Docker Compose. What that enables is this idea that you can build a self-healing app for any kind of expected failure modes. Like maybe the API is temporarily unavailable when my web component starts. By the time it's restarted, everything's fine. If the API goes unhealthy, then a replacement container might get started, or the container might be restarted depending on how you set things up in your orchestrator. So it stays online. It can manage itself, and that's where all that stuff kind of comes in. This is the bit that I talked about earlier. You don't have the option to model the startup order of different components in most orchestrators because it doesn't let them work effectively. So that's why you have this kind of logic inside your container so that it can talk back to the platform and tell it whether everything's good to go. Okay, and I think we get, we've got a nice little diagram here. So this is just to try and make clear where the dependency checks come in, where the health checks come in. So walk through this bit by bit. When I first create my container, it starts up and it's in the status created, and it runs the dependency check first of all because that's part of the startup command. So to take the example of the web component that's going to go and check the API is available. So then maybe it goes to the status exited because the dependency check failed, so it didn't start the application, so the container goes straight to the exited mode. And then what happens is the platform, Compose or Swarm or Kubernetes, restarts the container. So it's still the same container, but now it's up. It has time for its own health checks to run. It comes back as healthy. So it's been restarted and it's working again now. And then at some point further down the line, the app fails. It goes unhealthy. And so it fails its dependency, its health checks for the streak that flags it as being unhealthy, and then it gets replaced. So number two starts up, and by this time, the dependency check happens and everything's up and running. So it's all good. So this is the kind of the consistent life cycle that will keep on happening. Maybe with container number two, when it starts up, the dependency check fails and it gets restarted. And then it runs fine for several days, then it goes unhealthy, then it gets replaced. All that's happening and being managed for you by Docker or by Kubernetes or by whatever, because you've built your image and you've modeled your application in your YAML files with enough information for the platform to know whether this thing's okay or not, and for it to take repair action if it goes wrong. Okay, so that's that bit there. So there's this last line here, which is you need to be careful about what you do with this stuff. So your health check is going to run every 30 seconds or every 5 seconds or whatever you configure it. It needs to be useful enough so that when it says your app is healthy, you're pretty sure that it is. So it should exercise some kind of sensible path through your application and touch some points that is the home page up? Is the status page up? Is the checkout page working correctly? Do I see a product list? But the more logic you put in there, the more effort it will take to run that health check. And it will use, some of the resources that your application, this is your live application. So I've got users running their workload against this app in my container, and I've also got my health check running. So you need a good balance of making sure you exercise enough of the app to be confident that it's really healthy or not, but not taking like 10 seconds to run through a bunch of features and maxing out the CPU while you do it, because that's not going to be healthy. Dependency checks are slightly different because they only run at startup, but you only want to check something that your app definitely can't run if it's not available, and you can do something about it not being available. So if your app talks to a third-party payment service, or sends SMS messages to a third-party service, you probably don't want that stuff in your dependency check, because your app wouldn't start if that third-party service was unavailable, and that's something you can't control. So these things are really powerful. You should definitely be putting these things into your images, health checks and dependency checks, when you're getting these things ready for production. But you need to be careful about the logic that you execute. Okay, so there's a lab in there. If you've seen previous episodes, every chapter ends with a lab, which is like sets you a problem for you to go and solve by yourself. So putting into practice the stuff you've learned in the chapter. I don't walk through them in the episodes because that defies the point. You'll see that here there are a few hints. There's some goals of what you need to achieve, and there's a solution up on GitHub if you don't get time or you can't figure out the way to do it yourself. So here it's pretty straightforward. So there's some examples that you can go and check out. Okay, cool. So, right. So there's a couple of questions here. Let me go and quickly check Slack as well. Where's my Slack? Oh, that's good. So we just got in the live stream there. So Madden says, apologies if it's Madden or Maiden, I'm not sure. Should I use Docker Swarm anymore because it's perhaps not when we support it? Like, great question. So Docker Swarm is the clustering technology that's built into Docker. We have a whole bunch of episodes coming up about Swarm, how you use it, and how you can run like production grade containerized applications using Docker Swarm. It's an open source product. It's part of the Docker engine. So when I'm running Docker, I can run a command and switch to Swarm mode, and then add lots of servers and build up my cluster. It's part of the ordinary Docker engine, so it's supported in the same way that any open source Docker Swarm is supported. There's also an enterprise version of Docker, which comes with kind of paid support called Docker Enterprise, and that's now owned by a company called Mirantis. Now, in the Docker Enterprise product, there are two orchestrators. So I can run Docker Enterprise on 50 servers or whatever, and I can say I've got, I'm using 20 of these as Kubernetes and 30 of them as Docker Swarm, and it can manage them both. And Mirantis have said that they've got no plans to discontinue Swarm support. Only recently there were some major new features got added to Swarm, so it's alive and well. It's a really nice little product to have. So I would not be afraid about not using it. The thing about Docker Swarm, and if you stick with the series, I hope you will, you'll see it's really easy to use. So it uses the same Docker Compose format. So as you're going through your Docker journey, you start with Docker, you're going to go on to Compose, and then when you're ready to go to an orchestration platform, Docker Swarm uses the Compose format. It adds some extra stuff because it can do more than Docker Compose can, but it uses the same format, the same structure. So it's nice and easy to learn. It does a lot of what Kubernetes does. The big downside with Swarm is that there aren't any managed Docker Swarm platforms. So I can go to Azure, I can spin up a Kubernetes cluster. It's managed for me by Azure. I don't have to run any VMs or run any startup scripts. I just get a cluster. I click a button, I say I want 50 nodes, I get 50 nodes. There are no managed Docker Swarm products, which is a shame because it means people tend to default to Kubernetes, and there's a huge learning curve to Kubernetes. So you need a good book to take you there. But Docker Swarm is perfect for data centers. So if you've got a team of kind of ops people who are looking at running something in-house, Docker Swarm is a much nicer way to get started because the management overhead of Docker Swarm is like kind of tiny compared to Kubernetes, and the learning curve from Docker to Swarm is much shallower than from Docker to Kubernetes. And the reason I include Swarm in the book is because you get a feel for how orchestration works. A lot of the patterns are the same in Kubernetes, and the work you put into Docker Swarm, you're still running Docker containers, you're still using Docker images to build them, and that's the same. That's also true of Kubernetes. So Kubernetes just runs Docker containers from Docker images. So all the things you learn about Swarm will apply to Kubernetes, but it's modeled in a different way. The modeling language is completely different and much more. There's much more configuration of what you can do with Kubernetes. Is a much more powerful product than Swarm, but it's much more complicated. So if you're considering the two and you're a beginner, start with Swarm and get a feel for it. If you're moving to the cloud, you're probably going to want to learn Kubernetes. So follow me on Twitter, and sometime next year I'll be doing this same series for my Kubernetes book. If you're running in-house, then seriously give Swarm some thought, because if you've got a team of people who are used to managing servers and VMs, getting them to manage a Docker Swarm cluster is way easier than getting them to manage a Kubernetes cluster. Okay, so let me. I'm still in this view. So let me switch back to this view. So that was it for episode 7. We looked at health checks and dependency checks, and we looked at why it's important to build that stuff into your images. I hope you found that useful, and we'll be back again tomorrow. Tomorrow's observability. So the other big thing with running applications in containers is I can scale up as much as I like. I can have dozens of my API containers, and they're all printing these logs like mad, and I don't want to be looking at log entries to see what's going on. So the container world has a different approach to monitoring. The most popular tool is a tool called Prometheus, and we will learn all about that tomorrow in Learn Docker in a Month of Lunches. So I hope today was good, and I hope to see you again tomorrow. Thanks.